Hi. There were by Sam Harris and Jordan Peterson, and Dr. Peterson's claim early on in their debates was that Sam Harris's ideas and thoughts weren't Darwinian enough. And I am currently on my channel reading Consilience, or going through the book Consilience, and sharing its topics. And Consilience is written by Dr. Edward O. Wilson, Professor Emeritus of Biology at Harvard. Consilience is about the idea of unity of knowledge, and in that time, uh, Dr. Wilson again pretty much claims the same thing, that these ideas are of Darwinian ideas, or Darwinian ways of thinking are more important than Newtonian ways of thinking, or reductionist ways of thinking. And so a lot of people talk about this Darwinian notion, or these Darwinian notions. I'm a biology teacher, so these ideas interest me. Uh, but for application to social behavior, these are these are very difficult things to discuss. And one of the things in society today you get accused of is social Darwinism. This idea that that there's a force of Darwin's natural selection on society. The problem with that line of argumentation is that Darwinian mechanisms impact society, because they impact us as they are the reason we are kind of what we are. So I'm not for a social Darwinism, but I do think it's important for all species to understand evolutionary principles, because it is a helpful way of thinking. So here are kind of my thoughts on ways to apply Darwinian principles to social structures. And in my opinion, this kind of thinking allows, or calls for three building blocks of evolution, that structures of evolution that we're going to discuss, kind of to help you learn to think about social behavior in a Darwinian manner. A couple of things I'd like to point out off the bat is you need to get rid of, or there's a need to get rid of some of the myths about evolution, if you're gonna think in a Darwinian manner. For example, a lot of people, when you're talking about adaptations, would take the idea that species should want to make this sort of adaptation. So you have a mouse would want, a desert rat would want to have X amount of tubules in its intestines, or from a behavior standpoint, the cat should not want to have some sort of behavior, or whatever behavior you want to get it. But this idea of wanting, when you're discussing optimizations for adaptations, really don't hold weight. These ideas where you have organisms outside of the human organism, outside of our species, that wants to make some sort of adaptation is kind of faulty. So you always got to limit your personifications. Limit your personifications over these topics, and that's a helpful thing. Another logical myth about evolution is that there's such a thing as group selection. This idea of an animal behaving for the good of the species. Sapolsky in his Stanford lectures that are on YouTube, he talks about this wildebeest being pressed, this old wildebeest being pressed to the river that's teeming with crocodiles, and everybody's like, well, that guy's doing it for the good of the group. And Sapolsky comes back and he says that if you look back further, you see a bunch of the other wildebeest pressing that elderly gentleman to the river. He's not going there on his own. The end of the day, what we've got to remember is animals, including us, behave to maximize the number of copies of genes they're going to leave in the next generation. And that, we used to talk about, it's survive and reproduce. or the kind of the tenets of fitness, this what makes an organism fit. But it's more so the reproduction part that's really the driving force of kind of these ideas. So the first thing that you need, the building blocks of Darwinian thinking. Okay? The building blocks of Darwinian thinking, things you need to understand if you're going to think in a Darwinian manner about society or about biology or about pretty much anything else. If you're going to consider things, there's ideas that you have to have built at the foundation. These three building blocks are individual selection. Second is kin selection, and then the third is the reciprocal altruism. So we're going to talk about each one just for a brief moment, and then we'll finish up. So individual selection is the behavior of an animal is meant to optimize the number of copies of its genes. It's an organism or a species is competing. It's doing the things it needs to do to maximize the number of genes it will pass to the next generation. This is kind of the idea in the book Selfish Gene. This is what our genes want to do. This process of individual selection is constantly bring about an organism that's more adaptive, which is kind of the whole idea or point that a species is trying to do. It's trying to become more adaptive. The more adaptation, the more adaptive that a species is, the more it has the ability to survive. Because you could put yourself in multiple environments, and in those environments you could become a little bit more successful. Or, also, when you put yourself in different environments, your body is coded for different proteins that start to emerge based on being in that new environment. So even then, new strategies of adaptation or new outlines of adaptation could be given. Individual selection, like most types of selection, is driven by both natural selection and by sexual selection. And so natural selection would be kind of the specific traits that continuously grow, that continuously grow and change within the species. The speed of a cheetah, kind of you could even look down to the biomechanics of it, the size of the heart, the size of the intestines. Okay, these things are caused by natural selection, and the individuals who are selected for those certain traits, or traits that are selected for by these processes, are more adaptive. They work better. But they're optimized. They're optimized for that specific purpose. And behavior could be looked at the same way. So that's natural selection. Sexual selection are the traits that are based on wanting to attract a mate. You can think of peacock feathers. You can think of antlers on all the deer and the moose, the elk population, where the elk are attracted to the patterns on the antlers of the males. So that's going to play a role in individual selection. Okay. The second building block of kind of, if you're going to think about Darwinian, you're going to think in a Darwinian manner, the second building block is kin selection. So this idea of kin selection, where evolution selects for the organisms that are cooperating with their relatives, is something you see a whole lot of in biology. Animals kind of have this obsession with kinship. I kind of go back to our culture. We're not very far removed from kind of your surname being very, very important to success. I know it's still important to success in a lot of places, but this is a very different way of thinking that we are under right now. We're kind of removing ourselves from kinship in a very interesting way. But if you go back a few hundred years, especially go back to the Bible times, if you look what Scripture lies out, these long lists of genealogies. There's an obsession with kinship, and that can be understood from a biological standpoint, because there is we are very interested in our relatives passing on their genes. And the same idea comes because the more closely related you are to somebody, the more similar your genes, so you would want your kin or your family to pass those genes on as well. Um, Identical twins, 100% same gene all the way down to, or all the way back to cousins of some sort would be examples of kin selection that we would see. So that's a building block of Darwinian thinking, or Darwinian thought, is this idea of kin selection. One of the things when I think about kin selection, from a psychological standpoint, I think of Freud, kind of always saying that everything was in the family. A lot of the psychology problems, a lot of the neurosis that occur come from familial disputes, and for us, brilliant creatures who have consciousness, this relatedness to our family is a very difficult thing to navigate. But at the same time, we're very tied to them from a genetic and from a biological standpoint. The third building block of Darwinian thinking, if you're going to use Darwinian processes, the third building block to understanding these Darwinian processes is reciprocal altruism. This is a behavior whereby an organism acts in a manner that temporarily reduces its fitness while increasing another organism's fitness. So it's essentially cooperation, and where you're going to forego competition for a while to kind of be at peace. I'm not sure if I don't think he coined this phrase, but Sapolsky talks about the rock paper scissors equilibrium. We're going to cut back competition and aggression, and at times that hopefully leads to cooperation. This reciprocal altruism idea is when you move away from the natural biology and get into the social realm, sociobiology, for the people taking my class next year. Once you get into this reciprocal altruism, now you can understand a lot of the things that it seems like we've encountered as a species. Free speech comes to mind in terms of reciprocal altruism, partnering up with families, communities, societies. The benefits of reciprocal altruism are pretty deep. One of the biological theories that arose, or the evolutionary theories that arose from reciprocal altruism, is endosymbiotic theory, and this is the theory where it's proposed how single cell organisms became multicellular organisms, which is obviously a pretty important understanding that we would need to have. So endosymbiotic theory says you have this cyanobacteria, this photosynthetic bacteria, and that photosynthetic bacteria was taken in by a larger bacteria substance, and that larger prokaryote now had the abilities of that cyanobacteria, that photosynthetic bacteria. The same thing is proposed with aerobes, the bacteria that could carry out cellular respiration. The same thing can be said for that an aerobe was taken in by a larger bacteria cell, and that larger bacteria cell now had the processes of that aerobe. So it grows, it becomes stronger. Now, endosymbiotic theory is not law; it's not necessarily, but it's an incredible mechanism to think by, because if that, and this is where I'm going to tie it back to consilience. It takes multiple properties from multiple species to help grow and adapt or new species, or to adapt certain species to what it is they need to survive in that new environment. This is what thinking in a Darwinian way leads you to, because you're more focused on adaptation strategies, you're more focused on survival strategies, you're more focused really on strategy in general, rather than the reductionist view of taking everything down to the smallest detail and then building it back up. Again, I want to make sure the physicists, the physics people, the chemists, the Newtonian way of thinking brought us quantum mechanics and incredible mathematics and incredible technology. It is a brilliant way of thinking, and some of the most brilliant people I know do this for a living. But thinking in an evolutionary mindset is also very important, and learning these ways or learning these selection mechanisms in how organisms go through and experience natural selection can also aid you very much in thinking about ways to think and different ideas about knowledge coming together, which is my goal as a teacher, is to help knowledge from multiple disciplines and multiple facets of life come together and give kids a meaning that they can learn from. All right? Thank you.